Oh, hello everyone. Welcome to another problem. Um, we are going to do um, the next problem. This is problem number 9 from JEE 2024. Okay, it's actually an interesting problem. I uh, I like it. All right. So you have a ball. There are two balls will be thrown from two different places on the x-axis. So one will be thrown from here, another will be thrown from here. And this x-axis, this L and this origin, and the ball going to be hit. They will hit depending on how they're thrown, right? So, like one ball comes out, and another ball may hit over here, or one ball can be, and another ball could be in the same amount of time. So depending on how it's thrown, they are going to hit at different places. All right. So let's look at one scenario, like over here, this one. So it's thrown at V0, and this is theta 0, and this one is thrown at, they give angle 180 degrees minus theta 1. So this angle is theta 1, and this is thrown at some suitable initial speed. They're not the same speed necessarily, okay? So there are two settings. If this angle is like that, the stone will hit the ball after time t1. So this time t1. If the so let's work that out. So that's one condition. So time, if you, let's set this up. So with the coordinate system y. So look at this y component, both velocity will be positive. X for this will be negative and X for this will be positive. So it's going to look like at any time X, let's call these guys X, and this guy's X bar. So X 0 is 0, V0x is V0 cosine theta 0, V0y equal to V0 sine theta 0, and for the y0 is 0, and of course V0y, and I should have written this over here, V0x equal to V0 sine theta 0, ax equal to 0, ay equals to minus g, and the time at some time, arbitrary time t after this initial time. So this you can write down. So at this time, what's the velocity? What's the x? What's velocity x? Velocity y? What's y? We really don't need this information, looks like. So we just write down for x. So x equal to v0 cosine theta 0 t. That's all, because the ax is 0. And y equals to v0 sine theta 0 t minus half gt square. So this is equation 1, equation 2. Now for this other one, so this is for the one situation, and for the other one, I'll get, for this I'm going to get x0 equals to L, v0 x equals to minus v1 cosine theta 1, y0 equals to 0, v0 y equals to v1 sine theta 1, ay equals to minus g, ax equal to 0, and if you don't want to get confused with things, we might put a bar here just to distinguish these guys from the other guys. And at some arbitrary time t, I'm going to have a v x bar of t and vy bar of t, and we're going to get x bar at that time and y bar at that time. So writing down the equations for this will be x bar equals to this plus this t, right? This is going to be L minus v1 cosine theta 1 times t. So this is equation 3. And y bar will be is 0, so this is going to be v1 sine theta 1 t minus half g t square. So these are the 4 equations. And now let's look at the condition for t1. So t1 condition is theta 0 is 45 degrees and same as theta 1. So when that's the case, we get x equal to, at this time t1, I get v0 cosine 45 degrees, so it's 1 over square root 2 t1, this is t, and y at this time I get is v0 over square root 2 t1 minus half g t1 square. This, and x bar, guys, I get L minus v1 1 by square root 2 t1, and y bar equals to v1 over square root 2 t1 minus half g t1 square. Okay, so in here x is x bar and y equals to y bar for them to hit. Now from y equal to y bar, you can see that these guys cancel out. So from there you can see this equal to that, so you get this equation, and you can cancel these guys out, and from here you can say that v1 has to be equal to v0. So this means v1 equals, and now I can use over here x equal to x bar, this equal to that, and this, using this inside there, v0. So you can say I bring this on the other side, I get 2v0 over square root of 2 t1 equals L. So t1, so this is square root 2 now. L over v0 is square root of 2. So this for t1. Now I need to do a similar thing for T2, and let me pause and clean up and so that I can present that T2. Okay, so now we do T2. So for T2, it's like maybe someplace T2. It's for another trajectory, T2. They're going to hit if theta 0 equals 60 degrees and theta 1 equals 30 degrees based on that. All right, so I just plug in there. So we need x equal to v0 cosine 60 degree is half t, and y equals to v0 is squared 3 over 2 t minus this is T2. They're hitting at T2 half g T2 square, and x bar equals to L minus square 3 over 2 v1t T2. I'm going to use T2 here, and y bar equals to v1, and sine 30 degree is going to be half T2 minus half g T2 square. Now again, x equals to x bar and y equals to y bar. That's the heating condition. So if you bring it here, is we have a L minus squared 3 over 2 v1 T2 equals to v0 T2 over 2. And from these guys going to cancel out, and I'm going to get a v1 T2 over 2 equals to a square root 3 over 2 v0 T2. Of course, 2 will cancel out from this, and so this will give me v1 will be square root of 3 v0, and T2 cancels out. So plug in here, then I'm gonna get L minus square root 3 over 2 square root of 3 v0 T2 equal to half v0 T2. So this L minus 3 over 2 v0 T2 equals to half v0 T2. Bring it there. L equals to 2 v0 T2. So T2 equals to L over 2 v0. And now we have to do T1 over T2 and then square it. So this is L over v0 square root of 2, L over v0 times 2, square it. So L cancels out, v0 cancels out. So this becomes 2 over square root 2 square root of 2 square equals to 2. So answer there will be 2. Yeah, a lot of algebra, but pretty straightforward. Just have to follow the instruction that's given. It's coming from like first 2 or 3 chapters of mechanics book. Right. If you like this kind of problem solving, there's more at this website. Okay, talk to you another video. Bye.